Thank you. I'm going to present a word that I call co-effects. It's a catchy name. It's basic calculus that tries to model how your computations depend on some context in which they execute. So what do I mean by context? I'll borrow an example from a talk that was here just before lunch, where they had DSL that you could compile to different environments like CUDA or OpenCL or desktop. And that computation had some context dependence because some operations you could only run on desktop, some you can run on OpenCL. And this work is trying to give you some general mechanism that you can use to capture different context-dependent properties. Like what environment is that where you can evaluate your computations. So this is related to effect systems. Effect systems give you a way to model what your computation does to the environment, what effect it has. And this is captured by a lot of effect systems, and you can model these properties using monads. So the idea of effect systems or monadic effect systems is that you attach some additional information, that's the sigma, to the return type of your computation, and that tells you what happens to the environment. The thing that I'm presenting here is trying to do a thing that's in some way dual. So we want to track what requirements we place on the environment where the computation can run. And this is modeled by attaching some information to the variable context of your computation. You can look at this just syntactically, and then it looks very similar. I'll show you some rules that show that there is actually some difference even from the syntactic perspective. But when you look at the model behind the idea, which is what defines how this calculus works, then that's very different because we're using a variant of comonads, and this actually means that we're adding some additional structure over the context. But let's look at this just syntactically for now. So this is a simple function that you could write in some distributed programming language. And what's happening here is that we added the access keyword to our programming language. And when you're writing some code, you can use access to get some resource that comes from the environment. So this example gets handler to some database, then gets the current date, and then it selects events that happen after the current date. Now, if you, with the co-effect type checking mechanism, what you would get is that the type of the function tells you, or the type of the body tells you, this is some code that needs access to resources, events database, and current date. By the way, this is very similar to implicit parameters that you can write in Haskell if you're familiar with that. That's quite closely related. And there's interesting thing happening when you do lambda abstraction, because when we construct this lambda, what happens is that we get some information about the body. The body has some context requirements. It needs database and current date. But when we do the lambda abstraction, we can split these requirements between the declaration side. So that's information available in the current context. When you define this function on the server, there's database is there. You can capture that reference to the database. And you get a function that requires the remaining resources. So you can capture database on the server, create a function that needs just the current date, send it somehow in a distributed language to the client and run it there. This is one difference between this work and effect systems, because in effect systems, all the effects of the body usually get captured by the function. So here we can perform some or get some context requirements, satisfy them at the declaration site. Another example, which I think is more basic, but it nicely demonstrates what's happening, is tracking neededness. So the idea is, previously we annotated the context with a set of resources. Now we can annotate the context with a Boolean, which is 0 if we don't need any free variable from the context. So now we are actually talking about the free variables in the context. So 0 means we're not accessing any variable. So for example, if you have constants, and 1, the annotation 1 means we are accessing some variable from the variable context. And the card-fact system has interesting rule for application, which in this case looks like this. So we have some function, or rather some expression that evaluates to a function, and the evaluation of this expression either requires or doesn't the context. And also the function types are annotated with a Boolean that tells us whether the function needs its argument. So if you have constant function, it will be annotated with 0 and so on. And then we have some argument. And now the interesting thing that's happening here is that we only need the context if either the expression representing the function requires the context, like this. And in that case, we definitely need the context. For the argument, that's this bit, we only need the context if both the function requires its argument and we need the context to evaluate the argument. If the argument doesn't need the context, then even if the function does use the argument, we still don't need the gamma here. And similarly, if this is a constant function, then I don't need to evaluate this argument because I can just call it with some empty value. This is actually reflected by the comonatic semantics, and I don't have time to go into this, but briefly the idea is that well, monads attach some data structure over the result type. And with this word, we attach some data structure over the context type. So if you have function or expression that's defined in some variable context, then that gets modeled as something over the variable context to result. And this thing for neededness, that's some maybe data type, where if you have C0, then that means you can give the function nothing. If this is C1, then that means you actually have to give it the context, so you have to give it just case with the values. So you couldn't do that with monads, because with monads, the context doesn't have any structure over it. You always have to give it the context. You can only annotate the result. So just to summarize, what I'm trying to do is to find some unified system that you could use to capture these different notions of context dependence. And that's informed by some of the examples. Important part of it is also the semantics, which dictates how you need to compose things, how you should annotate the different parts in your typing rules, and how do they compose. There's quite a few applications of it to different areas. And what this gives you is some semantics for your context-dependent computations, and it also gives you some type system that you can use if you provide your own notion of context-dependent annotation. Thank you.